There we go. Okay, so these were cube roots. What we now need to deal with is, what about fourth roots, or fifth roots, or seventh roots? And the idea is going to be, they all kind of work in a similar way to cube roots, which kind of work in a similar way to square roots anyhow. So we're not going to do a whole separate section on fourth roots, and then a different one on fifth roots. We're going to kind of deal with them all together at once. I'd like you to turn the page to page 5, and we're just going to give a name to these things. We're going to call them higher roots, just kind of our way of talking about them all together. The first one we're going to deal with is the fourth root of 16. Don't say anything yet, please. This is asking the question, what number to the fourth equals 15? Don't say it yet. What number to the fourth equals 16? Okay, it's 16. So what number to the fourth equals 16? 2. Okay. This one over here is asking what number to the fifth equals 243. I think this would be a great time for me to show you the higher root button on your calculator. First of all, if you have a graphing calculator, you're going to type math. And actually, I'd take that back. You're not going to type math. We have to first tell the calculator what type of root we're going to take. And this is going to work if you have a graphing calculator or a scientific calculator. I first need to say do a fifth root. So I'm going to type no. I'm actually going to go back and do letter A. You're going to do B on your own in a moment. Letter A, I'm going to type in a 4 to say I'm going to do the fourth root. Then I'm going to go to math, and I'm going to go down to option 5, that root with like a little X inside there. Those of you with a scientific calculator either have like a button that looks like that, or the button that looks like this or something like that, but it's going to work the same way. You're going to type, for this one, a 4, then that button, then I'm going to say 16, and I got 2. I would like you to try to do, and don't say it once you have it, I'd like you to try to do the fifth root of 243. Which again is like me asking you the question, what to the fifth is 243? Answer is 3. These are usually not going to be nice numbers, and they're usually going to be things that we have to simplify. Well, here's the deal. When we were doing our square roots, I wanted to write them as a perfect square times something else. And our cube roots, I want to do a perfect cube times something else. Fourth roots would be perfect what? Perfect fourths. A fifth root would be perfect fifths, and so on. We don't have a list, but we're going to make our list every single time, and eventually we're just going to kind of know what these numbers are. So hold on. I want to do the fourth root of 128, which if you go to the calculator, will give you a decimal. I need to do some simplifying. Step number 1. I'm going to rewrite the stuff under the, well, to talk about this in general, I'm going to call this, rather than a fourth root or a fifth root, I'm going to call it an nth root. I'm going to say rewrite. Rewrite the stuff under the nth root as a number to the n power times some leftovers. As a number to the nth power times whatever the leftovers are.
Okay, Mr. Westbrook, I have a question.
Is it related to anything we are doing right now?
Yes. I can't believe you didn't answer that.
What is your question?
It's a foreshadow. Okay, so this A, I think 4 times 32, but 32 is also
Okay, so hold on a moment, because that's not totally right.
Oh, yeah.
Here we go. I don't have my list of perfect fourths, so I'm going to create this list every time I need it. We don't have to write it down every time, but what is 2 to the fourth? And we can use the calculator to do that. 16. Well, let's try. Can I divide this by 16? Yes. Okay, well, what is 128 divided by 16? Okay, so I'm going to break this down as the fourth root of 16, because that was a perfect fourth, because I got that by trying to make my list, and I only had to go to the first number. We're not usually going to have to go very far in this, in these. Times I was left with 8. Okay, so I want, rather than using 4, 9, 16, 25, those perfect squares, or my new list of perfect cubes, 8, 27, 64, those things, I'm going to use my list of perfect fourths that I never actually wrote out, and I'm just going to create my list as I need it. What's my first perfect fourth? 2 to the fourth, which is 16. That's a perfect fourth. That's something I can take the fourth root of. So I want to see, can I divide 128 by 16? And yeah, I was able to do that, and I got 16 times 8. If that didn't work, I'd have to go on to 3 to the fourth, which is 81, and I'd have to try to divide 128 by 81. But I don't have to do that because 16 works. Step number 2. I think you know what step number 2 is. Which of these numbers can you take the fourth root of? What is the fourth root of 16? 2. My answer here is 2 times the fourth root of 8, and I'm going to make step 2, take the nth root of the nth power and move that outside the root. Take the nth root of the nth power and move that outside. I took the fourth root of 16. I got 2. I moved that outside. Again, I'm not going to bother writing step 3. Step 3 is look at what's left. See if you can do it again. One really nice thing about these higher roots is you shouldn't have to do too much work. Our first number was 16, and we already broke this down quite a bit. We got things much smaller right away. Let's do another fourth root. The fourth root of 648. Well, what is 2 to the fourth? 16. Okay, go try to divide that by 16. Is it good?
No.
Okay, so I'm going to move on. 3 to the fourth is 81. And I'm writing these here. No, I don't think you always have to write. I think you can just use your calculator to create them and then see if they work. Does 81 work?
Yeah.
This is going to be the fourth root of 81. And what's left over? 8 once again. Okay. David, what is the fourth root of 81? 3, because that's how I created 81 in the first place. It was 3 to the fourth. This is going to be 3 times the fourth root of 8. And again, I only had to go up to 3 to the fourth, and I got it down a whole lot smaller very quickly. Are you with me here? What I now need you to see is there is no difference between these fourth roots and the fifth root and the seventh root that you're going to do on your own in a moment. The fifth root, well, my first fifth power, 2 to the fifth, which is 32. Try dividing by 32. Definitely things we're going to want calculators for. Can you? Okay. So what's the next number you should try dividing by? Which is? The next number you're going to care about trying is 243. Did that work?
Oh, wait, yeah.
So fifth root of 243 times, I think 4 is the leftover part. What's the fifth root of 243? 3, because that's how I created it. 3 times the fifth root of 4. You try the next one. Again, the higher the power, the quicker this is actually going to go, because the first couple numbers are going to, when you divide, it's going to get a whole lot smaller very quickly. I actually think that my first guess is going to do it. I think 2 to the 7th, 128. I think. Hold on. So 128 times 1920. 7th root of 128 is 2 times the 7th root of 1920. Is that good?
But how would you know that?
How would you know that's good?
Can you not divide 19?
Let's try again. You know what? Let's try 128 again.
Can you check by dividing 1920 by 7?
No, because we're not undoing a multiply by 7 problem. I'm undoing a 7th power problem. Can you divide by 128 again? Okay, well, that's kind of nice. 128, and what's left? 15, okay. 7th root of 128 is 2, so I'm moving another 2 out front. 2 times the 7th root of 15. That's going to be 4 times the 7th root of 15. One thing you could do, oh, you can't see anything I'm doing. You couldn't see that for the last moment. Okay, 4 times the 7th root of 15. One thing you could do if you wanted to check these is using your calculator. You could type this in and get a decimal. And then you could type in 4 times 7th root of 15, get a decimal, and see if they're the same decimal.
So would that be the same answer?
They should be the same answer, but this is the simplified version.
So then you should try to make sure you've done the right thing and multiple right.
It's not going to tell you, are you completely done? The only way to know if you're completely done is try dividing what you're left with by the first perfect seventh, the 7th, and again, you shouldn't have to go too far through that list.
I would understand how.
Okay, you got the 128?
Yeah.
Okay, so now I'm going to look at what's left. Is there anything else I can divide it by? Well, let me try, can I divide it by 128 again? That worked. I know what's left here, the 15, I can't divide by any perfect sevenths because my first perfect seventh is way bigger than 15. So I know here I've got to be done.
Yeah.
But here, since this was a bigger number, I'm going to try 2 to the 7th is 128. That one worked. If that didn't, I would then try 3 to the 7th, which is 2,187. Actually, I know right away that wouldn't work because that's bigger than the number there. So no matter what, you're going to have to look at the number and try to divide that by more things.
Oh wait, is our final answer 2 to the 7th is about 1920?
That is our halfway through answer.
Oh shoot.
I'm now looking at 1920, and I'm trying to break that one down further. Okay? That's how we deal with numbers. We just sort of make our list every time we need it. You shouldn't have to go too far in your list, and that's it. Personally, I feel like the variables are easier. Turn the page, please. Square roots, you divide the power by 2. Cube roots, you divide the power by 3. Fourth roots, what would you divide the power by? How about a fifth root? Let's do that over here. The fifth root of x to the 5th is what? X. Okay, well, that's kind of a silly one. What to the 5th power gives you x to the 5th? X. This one over here is asking you the 6th root of x to the 18th, which is like asking what to the 6th power is x to the 18th? X to the 3rd. So what's really the shortcut? I was dividing by 6. In this 7th root, I'm going to divide the powers by 7. And we're going to get x to the, help me out, 3rd, y to the 5th. If I want to do an nth root, a 4th root, a 5th root, a 7th root, a 21st root of a variable whose power is a multiple of that type of root, all we need to do is divide the power by that number. Divide the power by n. Divide the power by n. So if I'm doing a 6th root, I'll just divide the power by 6. 10th root, divide the power by 10. And of course, they don't always work out nicely, so we're going to have to do some breaking down. The 6th root of x to the 9th, I can't divide 9 by 6. I get a decimal there. So instead, I'm going to say the 6th root of x to the, well, I want a multiple of 6 that is less than 9. Don't overthink this one. 6. And what's left over? X to the 3rd.
So is it x to the 6?
Well, hold on. It is going to be x out front because the 6th root of x to the 6th is x. Then I need my 6th root, and what's inside the 6th root? X to the 3rd. Your answer, at least for now, is going to be x times the 6th root of x cubed. In January, we're going to see some weird way we can simplify this and actually turn that into a square root. Not right now, I don't care about that. We're just leaving it like this. The next one, the 9th root of x to the 23rd. Well, 23 divided by 9, that's no good, so I need to do some rewriting. I need x to a multiple of 9. 18 will work. X to the 18th, and you're left with x to the 5th. Okay, well, the 18th one was good. What is the 9th root of x to the 18th? X to the 2nd, x squared. X squared times the 9th root of x to the 5th. So if our power is not a multiple of the type of root, we're going to rewrite as x to a multiple of n times x to the leftovers. And again, I hope you're realizing this is just kind of like an extension of what we learned about with our square roots and then our cube roots from earlier today. I want you trying A and B. And again, make sure you're showing the rewriting step. I will not give full credit for the homework without seeing that rewriting. Usually just one line of rewriting, and then go. And we should be doing A and B. Have we simplified both of them? Have we simplified A and B? Okay. Just checking. Make sure you're showing that breaking down work. Send out an e-hall pass. Spencer, what did you do to x to the 16th? I like it. X to the 15th times x. Isabella, what about y to the 20th? Yeah, we'll just leave that. We'll simplify in a moment. So since you didn't do any work there, how about z to the 33rd? What about the z? Good. And then I'm going to go simplify, dividing those powers by 5 here. X cubed, y to the 4th, z to the 6th, and inside the root, 5th root of x, z to the 3rd, I believe. Okay. Next one, Taya, what did you do with the x to the 22nd? Good. X to the 21st, because that's our multiple of 7 times x. Keyshawn, what about y to the 35th? Right, but this is, I need to see the breaking down work to get any sort of credit. Can you break down y to the 35th? Actually, no, it's already a multiple of 7. Break down y to the 10th for me, please. Okay, or z to the 10th, if you say so. Good. And again, make sure I am seeing that breaking down work. This is going to give us x to the 3rd, y to the 5th, and maybe tomorrow we'll remember to turn off the phones. 7th root of x, z to the 3rd, I think. I am not giving you steps for how to do the bottom. The bottom steps would have just said number rules on the numbers, variable rules on the variables. So try A and B on the bottom. Looking for perfect fourths with my numbers, multiples of 4 for the powers. And in B, perfect fifths for the numbers, multiples of 5 for the powers.
Did you say both A and B?
Yeah, try both A and B. E, I'll pass. So now we're just doing A and B on the bottom. Put the number rules and variable rules together. Probably the second day when we come back. We'll review the first day. What was that? January 2nd. And I think we've got class on that Wednesday, so our quiz will probably be that Thursday. Certainly not the first day back. Almost there. Okay. All I know is there are 26 hours to go and 12 minutes. One more moment. Let's finish these up, and then you're going to help me break these down. Lucas, what did you do to 243? Yep. What perfect fourths did you find inside there? Oh, yeah, thank you. Yes. 81 times 3, good. Alexa, what about the h to the 7th? Okay. And Nicole, what about e to the 5th? E to the 4th times e. By the way, I didn't do this in this problem, but if I also had something like f squared, what would you do to that? You would just leave it because it's not even x to the 4th. It's not even big enough to break anything down. I feel like that happens in maybe one homework problem tonight. Then we're going to go 4th root of 81 is 3. 4th root of h to the 4th is h. 4th root of e to the 4th is e. Inside we get 3 h cubed e. Yes? Leah, what did you do with 972? Good. I tried 32, that didn't work, so then I moved on to 243. Cole, tell me about x to the 8th. X to the 5th, x to the 3rd, because that's our multiple of 5, okay. Leo, tell me about y to the 27th. 25 times y to the 2, that's good. Vana, what about z to the 101? Okay, let's do that one right now, though. Is 101 a multiple of 5? $100. That'll do it. And we're left with z to the 1st. Am I still? Oh, now I'm on the screen. Okay. So this looks like 3. X. Y to the 5th. Z to the 20th. Okay. And inside the 5th root of 4x cubed y squared z. What must I see in the homework to give you credit? The only time you wouldn't is if and I think the homework starts with some problems like, what's the cube root of 8? No, you're just going to tell me 2 and be done. But anything that involves breaking down, I must see that breaking down work with these. Let me stop.